This was released by Taboo Conspiracy last month, so let's see if he has destroyed the globe. He's going to analyze the photo of Denali, which is the tallest mountain in Alaska. All of this information is correct, so I plugged it into the Metabunk curvature calculator, and one would expect to see Denali on a globe. So what is Taboo up to? In the description, he says it would be awesome if we could create a true globe Earth curvature calculator that fixes this issue once and for all, because I'm really tired of using the erroneous globe Earth calculators. And what is this problem? Well, Taboo says, I know I'm right about the perspective issue, which is ignored by all globe Earth calculators. Yes, we're talking about the perspective hijacking Metabunk curve calculator, which was started over 2 years ago by none other than Nathan Oakley. Of course, Nathan showed the YouTube community that he was not even able to understand simple math concepts, so he could not back this claim. So does Taboo have the math skills to do this? Because he does say, I'm not certain of my method on how to correctly account for this. Let's find out. Now his video is just a series of graphics with no commentary, but he starts off with this graphic. So he agrees the curvature calculator gives the correct bulge height. However, if the height of the object decreases in size due to distance, law of perspective is entirely ignored. A standard curvature calculator assumes, for example, that the mountain size remains constant even though the distance between the mountain and the observer increases. This is not an assumption. The law of perspective does not change the mountain's actual size no matter how far away it is. When we talk about how big a mountain appears to be, we're talking about its angular size, and this is measured in degrees. Again, it's not the actual size that changes with distance. It's the angular size that decreases with distance. This is not a difficult concept to understand. Think about it. If somebody asks you, well, how tall is that mountain? You're going to tell them it's 10,000 feet tall. Nobody's going to sit there and go, from this distance, it looks like about 2 degrees in angular size. And if by chance you want to know its angular size, well, here's 2 ways you can do that calculation. So back to Taboo, how to make the angular size adjustment and determine what actually would be hidden behind the alleged curvature of the Earth. Step 1. Calculate the distance to the horizon. The horizon is 3 miles away for a 6-foot observer, and although Taboo used the horizon calculator, the curvature calculators use the same math to get the answer. So Taboo agrees the curvature calculator gives the correct horizon distance. Step 2. Calculate the angular size of the distant object as though it was located at the horizon. Now he uses the angular size calculator to get 65.3 degrees. And he uses the mountain's actual size and distance for this calculation. Now up here you can see that there is a problem with this calculation because this calculator assumes that the observer's line of sight is centered in the middle of the object. And since the observer height was actually 6 feet in elevation, this would have been a more accurate calculation, which is just over 13 degrees smaller. But once the object is about 13 times its height in distance, then either one of these calculations is close enough. In this case, the difference is 0.0065 degrees, which is about 7/1000ths of a degree, and you can see that it is even smaller than the resolution limit of a person with 20/20 vision, which is 17/1000ths of a degree. Step 3. Calculate the angular size of the distant object at its actual distance from the observer. In actuality, Denali was at 135 miles in this photograph. Let's instead assume Denali was only 50 miles away to demonstrate the damning effect of the angular size adjustment. Well, I'm not really certain why he's doing this. So again, he uses the angular size calculator. And since 50 miles is more than 13 times the height of Denali, this is the correct angular size. Well, so far this is correct. Everything follows the law of perspective. But he would have been more accurate using the 52-degree calculation for the 3-mile distance. So let's see where he's going with this. Step 4. Calculate the apparent size of the distant object in feet by dividing the result from Step 3, actual, by the result from Step 2, horizon. Multiply the answer by the actual height of the distant object in feet. And yes, I read that right. Calculate the apparent size of the distant object in feet. And here's his calculation. So what he's doing is dividing the angular size at 50 miles by the angular size at 3 miles, multiplying that times the height of Denali to come up with this new 1,369 feet, which he calls apparent size. And then he claims, and in other words, if Denali was visible, it would have an apparent height of only 1,369 feet at 50 miles distance. Well, the truth is that at 50 miles, Denali would have an apparent size of 4.4 degrees. Again, the law of perspective does not change the mountain's actual size with distance, only the angular size changes. So let's be honest, Taboo really has no idea how the law of perspective works. And most likely, this is the basis of his confusion, the flat Earth orthographic perspective view. Is how perspective works really that confusing for flat earthers? So in this case, Taboo made an erroneous calculation by changing the actual size in feet to an apparent size in feet. Next, we have step 5. Use a curvature calculator like Metabunk to calculate the understated hidden amount. And at 50 miles with a viewer height of 6 feet, we have a hidden of 1,473 feet. So again, Taboo uses the curvature calculator, and this time is to get the correct hidden amount in actual feet. Step 6. Step 4 minus Step 5. If Step 5 is greater than Step 4, then the entire distant object should be hidden behind a purported curvature. And the answer is minus 104 feet. So Taboo claims that even though this photo was taken from 135 miles, once you make the necessary angular size adjustments, Denali at a mere 50 miles would be entirely hidden behind the claimed curvature of the Earth. This is not even close to being correct. So Taboo is making the claim that this is evidence that Denali would be entirely hidden behind the curvature of the Earth. Here's the problem. Not only does Taboo erroneously adjust Denali's actual size down to this ridiculous 1,369 feet, he does not make the same adjustment for the actual hidden amount of 1,473 feet. In fact, he even calls this the understated hidden amount, and I find that quite ironic, because this is really the understated amount. And when we do make the same apparent size adjustment to the actual hidden, we get 99 feet, which of course destroys Taboo's narrative because now the top of Denali is visible. And Taboo continues with, so what would have happened if I left the correct distance of 135 miles instead of 50 miles? At 135 miles, Denali's angular size would have been 1.6 degrees divided by 65.3 and multiplied by 20,310 feet would have given Denali the apparent size of only 497 feet, well below the revised Metabunk hidden amount of 11,615 feet, and much more impossible. Again, this is not even close to being correct because Taboo did not revise the Metabunk hidden amount. What he revised was Denali's actual size down to an even more ridiculous 497 feet. So again, the irony is that on one hand, Taboo says, I'm really getting tired of using the erroneous globe Earth calculators. So what does he do? He uses all of the Earth curvature calculations without adjustment to get the correct bulge height, to get the correct horizon distance, and to get the correct hidden amount in actual feet. And Taboo was the one who made an erroneous calculation by changing Denali's actual size to a much smaller size. At the end, Taboo said, this is only a work in progress. I welcome all reasonable revisions as this issue is rather complicated. Well, to be honest, the issue is really not that complicated. So here's my advice for Taboo and also flat earthers. 1. Perspective does not change the physical world. 2. Objects appear smaller due to perspective because their angular size changes, not their physical size. 3. Metabunk's curvature calculator works just fine. And 4. It might be time to wake up and smell the coffee because we live on a globe.